Anyone have any experience on virtualization? I have used virtualizations or virtualization softwares before. Raise your hand, please, if you have used such a thing. I have used virtualization. Okay, yeah, good. So what can you tell me about virtualization, Ibrahim?
Virtualization in the sense, you are asking about virtual box using
Yes, yes,
uh,
yes.
uh, we exchange we use for the operating system exchange
Mm-hmm.
for Linux for the lecture purpose we
Mm-hmm.
use.
Okay.
And
All right. So
for
basically,
our
what's kind of thing that you have achieved using virtualization?
um, uh,
So what is the end goal that you have accomplished when you're using virtual machines?
we can use without any problem happen to our main PC that
Mm-hmm. Mm-hmm.
and we can allocate specific memory like that.
Okay. Okay.
Uh,
Okay. Yeah. Good answer. So uh, they are let me give you like if you guys have used virtualization or not. So virtualization is a technology that allows you to run a operating system or a machine, you might say sometimes. I'll just call it an operating system on top of your running operating system. Okay, so you can run an operating system on top of your machine that you are already running. So basically that means you can run another operating system while you are working on your primary operating system. That is not possible if we do something like a dual boot. In a dual booting system, what we do is we normally turn off our computer. We might select another hard disk or we might select another part. By using that, we can interchange between our operating systems, right? So, for example, when I was at university, most of the time, um, my primary operating system was Linux at that time. So I was heavily using Ubuntu Linux at that time. And the main reason I liked it, it's like a little bit developer friendly and I like the idea of open source. But then again, there is this issue, like sometimes we need special software to be running, and most of the time there were some softwares that only specific for Windows only. At the university time, of course, I did not have operating system like Mac, so we were stuck with Windows or Linux. So I need to I could have run Linux or Windows as a virtual machine. So in that case, what would happen is I'd start my uh, basic operating system, or what we call is the host operating system in this in virtualization. We call the host operating system. So the host operating system is the operating system that is mainly you have booted up, and you can uh, run run the base operating system where you work with the application and all those things. And on top of your host operating system, you install a virtual machine. Okay, you install a virtual machine. So a virtual machine is a software that allows you to run another machine or another operating system within your host operating system. It's think like a program that allows you to run another operating system. Okay, so when we are running that kind of operating system, what will happen is when when uh, when we uh, when we want to run such operating system on top of another, we use the softwares called virtualization softwares. VirtualBox, VMware are such examples. So you guys might have used those things. Most popular option would be VirtualBox if you have like open source alternatives, but VMware is one of the commercially supported. So you can either use these things. So virtualization software will allow you to run another machine. We call the base operating system as the host OS, and the virtual machine that you are running on top of the virtualization software, we call that as a guest operating system. So we have host operating system and guest operating system. So uh, the rise of Docker, which is changing a little bit on virtualization, but the Dockerization or the we call basically containerization. The real term is containerization. Docker is another software like VMware. It allows us to run application in a virtual environment kind of a way. Okay, so um, we have the host operating system, we have the guest operating system. Then we can you guys might think, okay, when we are running the guest operating system, it needs certain resources, right? Certain resources like RAM, hard disk, and whatever the physical operating system need, keyboard, mouse, if you are working something like that. So those things should be provided. Otherwise, what will happen is we can't interact with the operating system. Sometimes we can't boot it up, and all those things gonna be a problem. So everything that the guest operating system is gonna have is gonna be shared what we have in the host operating system. So what we are running two operating system on top of each other, but the thing is we are not changing machines in our application. Okay, so we have one single application that's run uh, run the run two operating system which is sharing the things. Then what will happen is you might think, okay, you can easily think that this is something you need resources in terms of like if you're having 1 GB of RAM and you're trying to run two operating systems, it would not work, right? So you need a lot of hardware in order to run two operating systems. Since they are shared among the host and guest operating system, then it will be a little bit of a hectic thing to do. Okay, so one thing that we can do is uh, in this scenario, either we increase the hardware capabilities, or we can have uh, um, like things like combining multiple machines together and work on that. But that is good. That is good, but sometimes virtualization is taking a lot of resources. We might need to share a lot of things like hard disk space, RAM, and all those things. So then again, what happened is the GUI and everything we can interact with the guest operating system. And the plus side is when you are working on such applications, when you are working on such um, things, we have the option of uh, we have the options of running different type of operating system. Say, for example, your guest operating system is Windows and your host operating system can be Linux. That means I can run Linux within Windows or Windows within Linux. Either way it works. And they are connected via virtual network. So you don't have to worry about communicating with each other. They will be working as well. So one more thing that we can do is one more thing that we can do like this kind of thing when we are working such thing uh, when you are working such application, the virtualization sharing a lot of resources would uh, sharing a lot of resources will give us um, will give us a lot of headache in terms of running multiple machines. Okay, but it is used commonly out there. Okay, don't think like it is like a very resource consuming process. No, it is not. uh, Virtualization is one of the biggest softwares that is available out there. If you think about cloud architecture, cloud infrastructure, right now we are having. So everything that a huge machine have, we can share among users, right? We can share among the users. Say, for example, we have a huge high performance machine where it is, let's say, for example, where it has 1 TB hard disk and 16 GB of RAM. Then if you want to divide these resources among 4 users, say for example, each one of will get equal share. So that means 4 GB of RAM, and each one will get 250 GB of hard disk space. So you can have the virtual machine assigned to the users. They will be having the feeling, okay, we are using a dedicated software, but no, it will be like a chunk or a small section of a bigger machine. Okay, that's kind of business is out there. So don't worry about virtualization. Is like, even though it is taking resources to run, but it is a business that helps in a lot of situations. Okay. So then next what we have is the when you're sharing the resource, of course, when we start a virtual machine, we can interact with it. Say, for example, if you have a GUI, we can interact with it. Then we can work on the GUI as normal machines. You can use your mouse and keyboard and interact with them. So when most of the time when I was at university, we use virtualization to simulate some networking stuff that we had to do, like Windows to Linux file transfer, some networking activities. We were using that. But other than that, there are a lot of use cases like testing things out. For example, I don't want to hurt my primary operating system, but I want to run software, okay, which I do not believe that is like that might contain a virus. Okay, so rather than introducing that software to my host operating system, I might introduce that to the guest operating system. And if something goes wrong, I can just delete the virtual machine. I have less effect on my machine, and then that's it. Sometimes we want to try out things, we can do it in a guest operating system. And once we are done, we can just leave it. Our host operating system is remaining intact. Okay, so that's kind of that kind of use cases are there as well. Another thing that then we come across is in when we are working with Dockerization, we got another software like virtual. It is virtualization, but without GUI that we can run applications. For example, let's say I want to run a database. My preference would be I would be running a Postgres database in my machine. So how would you normally do that? If you want to run uh, Postgres, what you have to do is you have to install the binaries. You have to go to Postgres website or some open source project. You download the binaries and you install it, and it is in your operating system. Uh, then again, I want to run my SQL for some other project. So what I can do is then again I can download my SQL, run it. For some another project, I need to use Mongo, Redis. You get the picture. So at the end of 2 or 3 projects, I have like plenty of databases which is running on my machine. Okay, so I don't want that to be happening, right? It is sometimes these process start
Sir,
at
excuse me, sir.
yeah.
Sir, are you sharing a screen or we
No,
able
no,
to?
no, no, no. I am still not.
Okay, sir.
For noticing. So uh, the the problem is when we are working with such a scenario, what will happen is um, when you look at the plenty of databases that you will be installing in your machine, at the end of 3 or 4 projects, you will have a lot of database running. Some databases start at some database when you shut it down, and when you start up the application, it will be starting as starting starting at the beginning of the what do you call, we call those things startup application. So without you knowing, there is a database running in your machine. Okay, so it's think like 3 or 4 databases running, which you are not using, by the way. Okay, they are just running on the background. You don't know whether they are running or not. Sometimes they are consuming RAM or your resources. Those things will cost you, right? So there is a problem, and think about a lot of the time, uh, the the things if you have like port conflicts, that kind of things also can happen. It's rarely happening because in terms of databases, because normally they have like very vague port numbers, so it's not going to happen. But there can be a scenario in a place where, say for instance, you are running a certain version of Postgres. Okay, say for instance you are running Postgres 12, but there's a project that is coming to you which is running on Postgres, let's say Postgres 15. Okay, so your machine is installed with Postgres 12, but you need to run a new project which is in Postgres 50. Okay, so 2 different versions that we need to work on. Obviously, Postgre will be running on the same most of the time it's going to be running on the same port. So when you are working on 2 different databases, what will happen is it at the same time, same type. So if you are running Postgres 12, you have to stop it and you have to run Postgres 15 afterwards. Okay, so that's going to be a problem when we are thinking of running the same type of database within your machine. So it's going to be a hard to handle different version of the software. Either you have to stop it a singular version, otherwise you have to uh, um, otherwise we have to um, completely destroy the other one and start over. Okay. And what else? When we are thinking about when you're thinking about when you're thinking about these conflicts, uh, a, a technology emerged for a brief time. For a brief time, a technology emerged. Uh, for a brief time, I mean, still it is existing. Okay. There is a technology called Vagrant. Okay. It is running on virtual machine, but at any time, at any given time, you can start a virtual machine which will be serving you a database or a specific version of Postgres, for a specific version of MongoDB, that kind of thing. You can do that. Okay, that kind of thing is available using Vagrant. So Vagrant is a virtualization software, but it is using um, only for not running the whole operating system as we discussed earlier on, but a certain service. Okay, so we are not running the whole operating system, but a certain service. But of course, underlaying the service, there should be an operating system that is running, but it's a bare minimal one. Okay, the main purpose of running a Vagrant, a virtual machine, is not to interact with the operating system itself, but the service it provides. Okay, so we have let me run over again. So we have virtual machines where you can simulate the whole operating system. Then we have Vagrant. So the Vagrant is like not the whole operating system, but a certain service as in a virtual machine. Okay, so we are not taking the full capabilities of the host guest operating system, but we are focusing on specific service. So you don't have to install. You don't have to need. So you don't need to download the specific version that and it installed in your host operating system. You can run it as a guest operating system and you can work with that. So you guys have a look around virtual machines and Vagrant. This is like not all tech we are using those things, but not quite frequently as what we will be using in Docker. Okay. So by the way, one different that you will see in virtual machines and Vagrants, most of the time, virtual machines, it's coming with a GUI where you can interact, or maybe it is giving you a window where you can interact with the operating system, even if the guest operating system is not having a GUI to interact. Say, for example, some operating system comes within a terminal. In virtual machine, you get the terminal as well, not perfectly mouse moving GUI, but a simple one that you can interact with. But in Vagrant, you don't have that kind of thing. You won't be getting any GUIs or direct access to command line. You need to using SSH. You have to connect to that. So I think probably you guys have looked into SSH on our previous video. So I hope you guys know what SSH is all about. It's basically connecting to another computer via a terminal. Okay, so you guys can connect to another machine using a terminal that's like a remote configuration where you can remotely access another machine. So we talked about guest operating system using a VM, and we talked about Vagrant. Okay, so if you need more information, just have a look around this. It's going to be super helpful when you are moving in industry. Okay, although they might be not in use, it's really important to know the difference between Vagrant virtual machines and Docker. Okay, so let's go to the topic of today. That is gonna be that is gonna be Docker. Okay, so Docker is somewhat what we call, it's not a virtual machine per se, but it is um, uh, uh, it does something similar as a virtual machine, but the resources sharing part is little bit of a difference. Okay, so we will learn about the Docker architecture, then you will guys get a good idea on what's going on. Probably something like this. Okay, so we will look into Docker and how it's architect and everything right now. Just sorry. Think it as a virtual machine that you can interact and that you can work with. Okay, that's the simplest term that I can give. We'll see in action how Docker works and everything. But in order to know the difference between Docker and virtualization and Vagrant, you guys should know, at least if you have practical, hands-on experience, that would be great. But sometimes if you do not have that kind of thing, it's okay. We will just go run through all these things and see what's going on. So there are a couple of things when it is coming to Docker. So Docker is originated from the world of Linux. Okay, so when it is in terms of resource sharing, we have different mechanism. We have different file system in Linux operating system. By leveraging those, a new ecosystem or something like that was born. We call it Docker. Actually Docker is like it is not a technology but a name. So the technology behind is called containerization. Okay, so the Docker company, it is like the what do we call, the uh, pioneers when it is coming to containerization. There are other solutions uh, like Rocket and what is the other one? I can't remember. So there are like few other options, but they are not quite popular as Docker. So by using Docker, what we can do is what we have talked earlier on, like we can have our own virtualization kind of a solution where we can run our application and get things done. Okay, so we'll see those things. So you might probably think, okay, so you mentioned that this is coming from Linux world, then for most of you guys, it will be a problem. Like, okay, we are not using Linux. We have what do you call? We have Windows or Macintosh with us. Can't we use Docker? Luckily, you can. There is another software called what we call Docker Desktop. This one right around here. So the Docker Desktop is a way that you can run Docker in Windows and Macintosh. Okay, so if you are worrying about running Docker within your Windows or Macintosh, don't worry. You just need to download uh, Docker for either one of these things. But I would recommend, if you have Linux machine, a pure dedicated one, not in even a virtual machine. Um, Take a Linux operating system, a base operating system, or a main operating system, install Docker on it, and work on top of it. Okay, but if you do not have luxury, if you are in Windows or Linux that you can't leave for some reason, of course, you can try these things in running Docker desktop. Okay. Okay. So the next thing is if you are running on Windows, make sure you guys install Docker and Docker Desktop. So it's not gonna give you like the full experience that we see in Linux, but it is the same thing. You might need a little bit of extra resources, but it get the job done. Okay, so we'll see once you get Docker installed, what kind of things that you can do and what sort of things that you won't be able to do. So in order to learn Docker, there are a few things that you guys should know. Okay, there are like key terms, if I may say. There are like key terms that you guys need to learn when it is coming to Docker. So when it is when you are working with Docker, the most important thing is the Docker daemon. Okay, the Docker daemon, which will be running as program on the background, which will be corresponding to all the Docker commands and deployments. Okay, so list these things down. Okay, I'm not going to give you guys full introduction, but it's on your own. Learn these things. Okay, the first thing is that you need to learn about is the Docker daemon. Okay, it's like the deployer manager kind of thing. Then what we have is there should be a way that we can get the host operating system, or what we call in this, sorry, guest operating system, or in Docker world, what we call these things as images. Okay, so an image can be something like a base operating system. Okay, an image is like can be a base operating system. Say for example, you want to run Linux in your Windows machine, and in order to run Linux within your machine, what you have to do is you need to run uh, you need to have a Linux operating system, right? So how do you gonna get the Linux operating system? First, in virtual machines, okay, in virtual machine, what you can do is you can create a virtual machine and you can mount a USB drive or a pen drive, then you can install it. But in Docker world, we do not do something like that. What we do is we create an image. Okay, we create an image which contains a base operating system. So the fundamental thing about images, those are gonna be based on Linux, but I have seen some images now merging from Windows as well. So those images will be will be used. Those images will be used to get our base operating system. So there is images. We'll see images in action when you will get an idea. Then where do we get those images? Where we can find those images that we want? How do we get these things in our application? How are we going to find these images? What are the things that we have? So in order to do that, uh, um, Docker, sorry, Docker Hub. Okay, so in order to get the images that we are seeking, we have a place called a Docker Hub. Okay, we call these things as image registry. So basically, Docker Hub is giving us access to variety of images that we can find. Okay, say for example, I want image. I want an image with Ubuntu installed in it. Okay, Ubuntu. Okay, if I search Ubuntu, then you will get loads of images that is Ubuntu, and there is similar, you will get some similar things. So for example, if I use this image, if I get this image using Docker, I can run Ubuntu machine or uh, Ubuntu virtual machine kind of thing. We have a separate word in Docker, but for now I will call it like a virtual machine in my machine. Okay, in my in my host operating system, I can run an Ubuntu instance. Okay, so if I want some other flavors, like for example, I need Red Hat, okay, or Fedora. Yes, Fedora. Yes. If I want Fedora, I can get the Fedora image and I can run it in my machine. Okay. So there are like a lot of images that you can work. Say, not only image containing operating system, but there are containers containing services. Say, for example, Postgres, as I mentioned earlier, I want to run a Postgres instance in my machine, but I don't want to install that in my host operating system, which will run with with or without my knowledge. Sometimes it's start. So what I can do is I can find an image that is already pre-installed Postgres into it. Okay, so I don't have to install it. I don't have to download it. I can just grab Postgres image from Docker Hub and run it in my local machine. Then it will run Postgres on my machine. No worries. If I want MySQL, then there are other services like as well. Say for example, I want to run a popular HTTP server like Nginx. I can run Nginx on my machine, no worries. Okay, so I don't have to install Nginx and everything. And I want to test something in Python. Okay, most of the time you can download and install Python, but the problem is, say for example, there are many versions of Pythons available, 2.7, 3.10. Okay, so what will happen is if I want to run Python uh, in two different versions, easily, what I can do is I can download different versions of Python images and I can interact with those things without an issue. Okay, so how do I know what are the available versions and available images are there? So if I go to Docker Hub and say, for instance, a service that you guys might have heard, maybe we have a Docker image for that. Anything similar, anything that you guys have using? Don't ask for Photoshop or Microsoft Word or something like that, but I'm talking about a database as a service, something like that you guys see. Most probably WordPress, you guys may have heard of it, PHP, MongoDB, Node. So these things are like quite common. Okay. So say for example, okay, you might say, okay, not as image. What does this image do? So well, it's not this image, the not image containing pre-installed not image. Okay, so you don't have to manually install in your machine in your operating system. If you get this Docker image, then what you can do is you can interact with this Docker image without installing Node. Okay, Node is pre-installed in that machine, so you don't have to worry about that. So if I want a different version of this, okay, I need a specific version of Node, I can get that one as well. If I click on this version, and there is something called tags. Okay, these are like different version how they tag it. So right now there are a lot of lot of tags available in here. So there is the version not 2011.1 and the slim. Okay, there are like a lot of versions that you guys can see. You guys can see that the latest node version, if I'm not mistaken, it is 2011.1. But if I want for some other project, one legacy project, if I want node 12, I can like search. You guys can see that 18 point is there, and 12.01 if I say node tags. Maybe I'm finding that is not, but this one is exist. Say for example, I want to run a very old node version, which will be 12. Okay, so I don't have to install node 12 in my machine. I can just download this Docker image and we can work on that. No issues. So that's going to be helpful when we are working in application which are different versions or different uh, architectures. Also, uh, you might ask, okay, Node is installed. All right, that's fine. But what is the operating system underlying it? Okay, you can't run Node on top of thing. Yeah, you need uh, operating system to be installed uh, on top of. Okay, Node is not going to run on thin, yeah, as I mentioned. So there are different flavors as well. So if you like, okay, I know for sure my program is not running on Ubuntu, but it is running on Fedora. I can select, there might be options in here that I can select what is the operating system of choice. Okay, so in here you guys can see there is called 12.10.0 Buster, and we have 12.0 Buster Slim, and there is 12.0 Slim. Okay, so these are different versions of, I think if it is not mistaken, these are like Debian versions. Okay, Debian as operating system. So there are like Scratch, like a lot of versions are there, and there are like more what we call more compact versions where you don't have, like, the image is not going to be huge. In here you guys can see the compressed size for each of these things. Okay, don't worry, it's not going to be like this, but you guys can see like there are images called Alpine. Okay, based on Alpines. So these are like very small base images. That means the underlying operating system is called Alpine, and those are really minimalistic operating systems. Okay, they don't have so much of things. They have the basic operating system. See for yourself. This is bookworm, and one layer is around like 300 megabyte. But in terms of Alpine, they are like 43 megabytes. Okay, so you can see how small an Alpine image is compared to another version. So you can select what is the underlying operating system, what is the underlying node version. Likewise, you can select and cross work with different operating systems in this scenario. Okay, so it's going to be a plus point. So remember, we can have base images, that is like the payload operating system, or you can have pre-installed software like Node, Python, or any database server, any cache server, any HTTP server. You can have uh, so you can have these things in here as well. So that's going to be a plus thing. And what we can do in here is we look at these Docker images. Um, we can select the Docker image of our choice. Okay, so the next thing that we'll be thinking okay, how we can get these images, how we can run these things. Okay, so we'll see those things in action now. So make sure you have Docker installed. If you are in Windows or Mac, you have to have Docker desktop running. I'm running Docker desktop in my Macintosh. If you are in Windows, of course, you need to have that Docker desktop as well. Okay, so how do you know that once Docker is running, you will see an icon on your taskbar or task menu, so you know that it is running. Another way that you can find is go to your terminal, and if you say docker -v, then it should give that the version of Docker that you are running. Okay, so we know that Docker is installed. So Docker and Docker daemon is two different things. Docker is the command line. So the Docker daemon is responsible for doing the heavy task that we are about to do. Okay, so Docker is like a command line tool, and Docker daemon is where those things will be like executed or get instructed. So we have Docker. Uh, there are plenty of commands that you guys need to learn. Okay, so when you need to learn this kind of thing, it's gonna be a little bit of what we call a little bit easy thing that uh, these images are really easy to learn. Okay, and so you guys will remember these things fairly easily. Okay, first thing first, I have downloaded some images in my machine. Right now in my local machine, I have several what we call images in my machine. So I should be able to look into those images. What are the images in my local machine? Okay, so the basic command that I need to list down all the images is docker space images. So it will give a comprehensive list of Docker images that I have. You guys can see like I have plenty of images in here. Okay, some are like build step. We'll see those things in later on, but for your reference, it would be something like this. I'm not sure whether you guys can clearly see, but these are like some of the operating systems. So for example, I have an image called Ubuntu and 16.0. That means I have a base image called Ubuntu, and it is the version is Ubuntu 16.4. Okay, and I have Postgres. Yes, in here I have Postgres 15, and the base image is Alpine. Okay, so I have Postgres 15. I might have Postgres 15.4. There you go. So I have different version of Postgres as well. There might be very old ones. Postgres GIS, I think there's a variety of Postgres, but it's count. So it is like version 12. Likewise, I have plenty of images within my machine. That is, those are like the images that I have. So I can download these images, or I can get these images created within my if I use several commands, which will be doing in upcoming lectures. I can create these images, or I can download these images. So this is one of the images that I have downloaded. Ubuntu, this one. Okay, Ubuntu 16.04. So I know for sure that in my machine, I have Ubuntu 16.04 that I can run. So the command again is called docker images. So I can list all the images within my machine. Okay. So for instance, I want to get I want to get a certain image into my machine. So what is the command that I can get or download an image? Okay, the easiest form of getting an image is using Docker Hub, and its downloading mechanism, or what we call in here is a Docker pull. Okay, by simply executing Docker pull and the image name, we can download an image within our machine. So for example, there are like a lot of options out in here. Okay, I won't be downloading right now because it might slow my internet connection at this point. So, but say for instance, I want to download not this one, but let me check. Ubuntu. Okay, I have Ubuntu. This is the Ubuntu official image, and if I go to tags, I can get Ubuntu Mantic or Jammy, whatever the version I would like. So they give us the command to get this image into your local machine where or within your wherever you are going to be executing this. So the command is docker pull followed by the image name. Okay, so if you have a specific version like this, you have to give the name exactly. So the name and the tag is much more important. If I say docker pull Ubuntu, it will take the latest one, that is what we are having in here. Okay, the problem with docker pull just Ubuntu, we we get the latest version. Okay, sometimes when you are working on a project, when you are working on certain system, we need to be exactly sure what is the version that we are running, what is the version that we are doing the development and everything. Okay, so I need to be make sure that we are running or that we are using the correct version. So always when you are pulling an image, make sure do not use the terms like latest because it will change. What we have today as latest is not going to be the thing that we'll have tomorrow. The latest might change. But if you say for sure we are Docker pulling Jammy, then this is the version that we are really interested in. Okay, so you guys can see these images are really small compared to other images. So if I want Ubuntu 0.2407, what I have to do is I need to copy this command, or I can just type it in. I'll copy this, go to my terminal, clear this out, and hit docker pull and the image name. Okay, make sure the image name is followed by the tag. Otherwise, what will happen? We won't be able to get the exact version that we are finding or what we need. Okay, so this is going to be connecting to Docker Hub. Okay, it's going to connect to Docker Hub and get all the information. And you guys can see it is around like 28 megabytes at this point. So it is now downloading the Docker image that I need. So one thing that we need to know, obviously we will see these things in upcoming lectures when we are building Docker images, that Docker images are not like, in this scenario, it is like one big file, but in most of the time, Docker images are not a single file. It is gonna be what we call, a layer of files or layer. We can create a Docker image by using not a single file, but set of layers. Okay, by using one by one, we are laying on one top of another, then we will get a Docker image. But this is a base operating system. This base operating system is like the starting point. We'll see the difference between base operating systems and all those things later on. But for now, this base operating system is like the minimalistic thing that you can get and work with. Okay, so make sure uh, you know the command, how we can get an image, docker pull and the image name. So once you have pulled this, what you need to do is we need to run this image. Okay, you need to run this image and interact with that image. Okay, we need to run this image and you need to able to interact with this one. Okay, we will see how we can run a downloaded image. So I'm not gonna proceed with this. Let's assume that this one is downloaded, but I'm gonna use a separate image. Okay, so I will list my images once again. Docker images. Then I have Ubuntu, this one. Okay, so if I zoom out, you will see some more information, interesting information in here. I'm not sure whether you guys can see clearly, but I will copy these things in one go. So this is the image name, this is the tag name, and we get a unique identifier for um, each of these images. Okay, so this is Ubuntu's what we call Ubuntu's unique identifier. Okay, this one. So either we can use this image ID or we can use the image name and image tag to create an instance of it. So we have the image. Now we need to run it. We need to run this image. So if I run this Ubuntu image, I should be able to interact with Ubuntu operating system within my machine. Okay, right now I am in Mac. Okay, but using this image, if I run this, I would be able to interact with an Ubuntu machine within my Linux, within my Mac operating system. Okay, so what I need is either this image name and tag, or I need the I need uh, I need I need to run these things and check these things with my machine. So once I run image, I don't call it as an image. Um, Give me a second, guys. Okay, so we need to run a Docker image and we need to get interaction. So uh, once we run it, we call this as a container. Okay, we are downloading an image and we are running that image, and when we run that image, we call that as a container. So it within one single machine, we can, if you have enough resources, you can have multiple containers running. So how do we know what are the containers that running? So we take an image, we execute some commands, and we can run that image. By running that image, we mean we have a working environment. So what we will get in here is the in environment that we can interact. Okay, so we might need to interact with that environment and see what's going on. But before that, we should be able to, what are the running services available right now? What are the containers that is running at the moment? So you can use the docker ps command. Okay, if you execute docker ps command, right now I do not have any containers running on my machine. So you guys can see that the list is basically empty at this point. Okay, so there is no container ID, there is no image that I use, there is no commands, all these things. Okay, everything completely fine. But if I want, I can see what are the images that I ran earlier. Okay, what are the containers that was running, but no longer running at this moment. We can see those things by simply amending -a at the end. So you guys can see there are a lot of containers that I have executed but no longer running. Okay, these are like what we call stopped containers. These containers are no longer running. I can start these containers anytime if I want, but at the moment, these are like in like a stop state. The container is not running, like a sleep state. It's not executing anything. So you guys can see the benefit in here. If you have a Postgres service, you can run it while you are developing. But if you find yourself, okay, I'm no longer developing, you can just stop the container. And once you feel going again, once you feel, okay, I need to develop again, you can just start the container at that time. Okay, not all the time you need to worry about running it in the background, this kind of thing. It's gonna be something like you can stop it and you can work it afterwards. This kind of thing you can do in here. Okay, so there are a lot of images that I have executed but not running at the moment. Okay, but if I look at my current process, I don't have anything that is running. Okay? So bear in mind the command. So what I'm going to do is I'm going to run an image. Okay, I'm going to run one image. So I'll be interacting with the Ubuntu one. Okay, Ubuntu 16.4. So how I'm going to run this? Simply docker run image name Ubuntu. Let me give you guys more. Okay, Ubuntu colon 16.04. So make sure you have this image downloaded. If you do not have that downloaded, it will automatically try to find the machine image name like this one. It will download and then run. Okay, if you have it downloaded, it's not going to download again. Since I have, if you guys can see that when I execute Docker images, it is showing under my image name. That means I have downloaded this. So I don't have to download it again. But if you haven't downloaded it, you can just download this one. Okay. Now, if I hit enter, okay, just look at this. And there you go. Something happened. Docker run. And I'm still in my machine. I'm in my previous terminal. It is the same terminal that I'm using. Something ran, but it is not there. Did I execute it wrong? Or is it running? Is it running now? Okay, let's see whether it is running. So if I say docker ps, no, it is no longer running even. Okay, what happened here? So what happened here is Docker started running this container, Ubuntu 16.4. Since we did not give anything afterwards, since we did not say what to do with this image, the image is the container is created. As soon as the container is created, we didn't give any instruction. So basically, a base operating system like this, Ubuntu 16.4, it's gonna stop execution. That means it's gonna exit the. But in a case where you have like a database or something like that, they will be running within the current terminal, because we will see these things like we entangle these things as entry point. Okay, since normally base operating system, they don't have entry point. So what they do is they run the container. Since the container has nothing to do, it's gonna stop. We can see the ran container. If I say docker ps -a, I think, yes, in here you guys can see there is a container ID and the image that we have used. What is the command and when it was created and the status. Right now it is in exited status about 0 minutes ago. Okay, so that means I was able to run this container, this one, but it is no longer running. It was, as soon as I created it, the container was exited. So it is no longer running. Okay. So how we can retain or how we can make sure that we can interact with this container. Okay, the container just starting up and closing down, it's no use for anyone. Okay, it's useless. How we can interact, how we can log into the Ubuntu 0.4 image, the container that we have created. So we can do a little bit of a modification in here. So rather than say docker run Ubuntu minus C, I will pass some parameters. So docker minus IT run Ubuntu, whatever the image, and I will say bin bash. Oh, wait, sorry, bin bash beforehand. So, sorry. Docker minus docker run minus IT bin bash and Ubuntu 16.04. Docker run. Docker run. Okay. Check. This is the command. Okay, wait a second. Okay, sorry. The command is docker run, and you have to pass minus IT, okay, and the image name. At the end, we will have thing called forward slash bin bash. Okay, so bin bash is the command that we have. So earlier we just ran with docker run and the image name. Right now, what we are doing is we are giving extra parameters. Okay, I minus t and bin bash at the end. So basically what this command is doing, hey, when you're running this container, when you're, okay, I have selected image, okay, and I'm instructing Docker to run a container. When I'm running a container, it should interact with the um, container that we are running. And where do we gonna start interacting, or where we'll be attaching to this container that we are running right now? It's gonna be the bin bash. Okay, so we have to say when you're running the application, you have to stick, or we have to execute a program in order to start working. So how do you know that we have attached to this running container? There are two things. Earlier, you guys can see I was on my MacBook Pro. Right now, I am seeing root at some random number. Okay, so currently my terminal is pointing to not to my local machine, my MacBook Pro, but I am in a different machine. It's like I have SSH to another computer. Okay, so by executing this command, it is basically gonna be attaching to the running container. Okay, I'm attached to the running container. So I can, so this now I am in a kind of a virtual machine, or I can, in this scenario, you can say I am within the container that I just started. So how do I know? If I say pwd, it's going to show my root. And if I say see who am I, this command, and it will say I am root. Okay. So basically, I am right now within my within my container that I have created out of this Ubuntu 16.4 image. Okay, right now I have created a container. I'm attached to it. What I'm gonna do next, I'm gonna take another terminal. Okay, now you guys can see if I create another terminal, it's pointing to my local host. My terminal is attached to this MacBook Pro, not the container. Within here, if I say docker ps, now you guys can see this one I haven't touched anything, it is still running. So now if I say docker ps, it says, okay, this is the container ID and this is the image that you have used to uh, create that container, and this is the command that you are attached to it, and how long it was created and how long it was staying up. There are ports kind of thing, and it is giving me like short name. Okay, so the content identify this container, I get a container ID. Okay, so this is like a unique identification, but you know, this is kind of something hard to remember. So they give like a cute name or like a short name that we can refer this container. Of course, you can use the container ID or container name. Either way, you get a running container right now. Okay, so within this terminal, the previous terminal, I am still attached to the uh, Ubuntu instance that I have raised early on, or the container that I had run. So whatever I do right now, whatever the commands that I execute within this Ubuntu instance, as soon as I delete this container, everything will be gone. Okay, so if I want to run some algorithm in here, if I want to compile something in Ubuntu, if I want to install certain Python, if I want to certain application, whatever you do within this container, as soon as you destroy this container, everything will be gone. It is not affecting to the host operating system at all. Okay, the container, once it is gone, everything that is in there is also gone. So you guys can see that this is like a private sandbox environment where you can use to do your own research and execute and everything and get everything done. So it will be easy you to interact without installing softwares. Even though you install anything, it will be gone. So you're not caching a host operating system. Okay, so as a normal um, as a normal person would do, you can get everything. You can do curls, you can do anything in here. But if you are just like me, you can install Docker inside in here. Okay, we call that Docker in Docker, or Ding for short. I can install Docker in here and go another level down, and I have Docker in there as well. So Docker in Docker is also available, but I'm not going to do that right now. But you guys can see they have perfectly working. See, I can see the home and ls. This everything is gonna be in here. Okay, so I have a perfectly working guest operating system in my local machine. Okay, so as soon as I exit, okay, if I say exit in here, now I am returned to my normal machine, which is my MacBook Pro. And if I say docker ps, the container is no longer running. The container has stopped. Okay, it is not destroyed, it is stopped. So I can see docker ps -a. It will give me all the list of things. There you can see I have two containers with the same base image, but I have two containers that I have executed in here, at least three. So I have three containers which I started using this image. Okay, I have these three Ubuntu operating systems. Okay, I can even start these things again, but I need to attach. So I can say docker start and the image ID, or you can use the image name that they have given. And as soon as you do that, you guys can see it's printing out the image name itself, but it is no longer running again as I did not attach to it. Oh, sorry, it's running because I think I have bin bash command in here. So you guys can see it is running now. Okay, I stopped the container right now, and I started the container again. I ran the container and it is now running. So if I docker ps again, docker ps minus a, so you guys can see this one is up 24 seconds. And there is another image. I don't think I can attach to this, but if I say docker start and the image name, there is no failure. Yeah, that is not responding. Docker ps, still I have one running. What I'm gonna do, I'm gonna run another container like what I did earlier on, like this. So I'm gonna run a Docker instance, and I'm gonna attach to the interactive terminal, and the attaching point, or I'm gonna attach to this bin bash. That is the basic terminal that we see in here. So if I go in here and clear this out and Docker ps, now you guys can see I have two running containers. I have two running containers with me. Same operating system, but two different containers. So it's like I'm running two virtual machines in my computer. Okay, I'm not going to test my memory capabilities within my Macintosh. So I'm going to leave it as two, but you guys can see if you have resources, you can run these containers separately. There might be special use cases if you are building something like a cluster, that kind of thing, testing things, testing networks. You can use this kind of technology to accomplish that kind of thing. Okay, so you guys can see there are like cute names, short names that they have given. So you can uh, rather than naming using the name, you can use their name. So I'll show something like that. So I'm gonna stop one of these containers. I'll be stopping this one using the container ID. Okay, I'll copy the container ID and I can say docker stop. Okay, this is not gonna destroy it. It's gonna simply turn off the container. And if I hit enter, now you guys get the confirmation. If I say docker ps, now you guys can see this one is no longer running. This one is running, but I will turn it off as well, or stop it as well. I'll say docker stop and this one. In this scenario, I have used the name, so it works as well. If you have something really catchy name, you can give the name and it can be done. And if I say docker ps, now no images are running. No images are no longer actively running. No containers that is at the running state. So what what we will do? Um, what we'll do is we'll see how we can completely delete this container. Uh, okay, how we gonna delete a running container? So if I say docker ps, and it's not showing anything running, but if I say docker ps minus a, it's going to show all the stopped or exited ones. So I have a bunch of images that I have created for demonstration. So I have the docker container id in here. If I zoom out a little bit, you guys might see these things in container id such and such. So if I want to remove these containers completely, whatever did within that container is going to be gone forever. So if I want to delete this one, all I have to do is execute the command. So what I'm going to do is I'm going to copy these container IDs in a list. I'll show why. So I'm going to take in the next one. and 630 and all those things. And I have another one. So I have copy 4 Docker container IDs, not image IDs. Remember, these are container which we ran against the image. Okay, this is the image. And using the Docker run command, we have run a container. Now we have 4 containers which are either exited or just created. Even this one is not run even. Okay. So we have 4 Docker containers, which I no longer need these things. So how I am going to remove that? Simple enough. I can use the command docker rm. Okay, docker rm stand for docker remove. And I can give a single container ID. Okay, I have this single container ID, which will delete the image container ID which is having which will be deleted. So I won't, after execute this, I won't find a container ID at this. I won't find a container with this ID. Or if I want to delete multiple ones, all I have to do is sorry. All I have to do is combine these things or concatenate with these things with the space. That means I'll be removing the containers. Okay, remember containers with the IDs of these IDs. Okay, so after I execute this, I won't have the containers which containing this container IDs. Okay, so for the confirmation, you guys can see that the give us back the Docker container IDs that we just executed. Okay. Let me clear that. And I say docker ps minus a in here. Now, no longer those containers are there since I have deleted those things. Okay. And like that, we have created an image. We have ran that. We can execute whatever we want. After we are done, we can stop it. Or if you want to you delete it, you can just completely remove it. Okay. And there are other options where you can specify, okay, there are like um, there are like options where you can simply say, okay, as soon as I'm exiting, remove the local image. There are options. Okay, I'll show you guys one thing like this. So you guys can see docker run -it. This is the image and this is the attaching point. And if I say -rm in here, let's see it. Uh, is it rm or rm? Give me a second. Docker run rm. Docker run rm. Delete. Can't remember actually. Let me do a research on that. If I can remember, it was -rm, but I might be doing it wrong. Let's see image name. Maybe I'm doing it wrong. I'll get back to you guys. Can't remember exactly. But there are other options, such as if you like to give a name to your image, you can say name and let's say run decker, and of course it start running. If I say docker docker ps right now, and the name that you can see, the name that I have given. Okay, so if you want a custom name, you can also provide that. There are a lot of options out there, okay, that you can explore. Docker run delete on exit. Okay, I think I got it. So if I exit this one by simply saying exit, and you can see that docker ps, it's still running. You need to stop it. I will use the container id, command c, docker stop the container id. Okay, and if I say docker ps minus a, I should be able to see the image that I have created. So I'm gonna delete this one to give you, okay, I'll keep this one. The forget command was, so you can have the same name. If I try to execute this one again, it will give me an error because I have a container with the same name, so I can't have the name again. It should be unique, otherwise you can't identify it. But if you want to, if you want, right after you exit from this, if you want this Docker image to be deleted, you can append dash dash rm. Okay, so it will run the uh, container. If I go here and say docker ps, it will show, okay, this is the container. The container is still running. So remember, as soon as I exit this one, if I say exit, okay, now I am in my container. You guys can see I haven't executed exit. I execute exit, and now I am back in my machine. And if I say docker ps, yes, that shouldn't be here, but there should be a container with this name. But if I say docker minus a, you guys can see that image, the container is not even there. Okay, so the name that we have given, it is no longer here. The reason behind is, if I add minus minus rm as what I have done here, as soon as I exit from my container, the container will be deleted itself. Okay, so you don't have to manually delete it. It will be automatically deleted. So it's like, if you're in a hurry, you don't want to delete the containers and everything. As soon as you are done, your sorry, your container is gone. Okay, so if you care about not having a lot of containers, just like me, you can simply use that in order to get rid of the container as soon as possible. Okay. So we learned few Docker commands. So we look into Docker images, Docker pull, then we say Docker run, Docker stop, Docker rm. So there are like plenty of other commands. Okay, I'm not gonna go one by one, but we'll be using them as soon as we are progressing. So you guys can see there are a lot of commands that we can execute: run, exe, ps, build. We use pull. There is push. We use images. What else we used? Yeah. So basically, we use rm. So rm will remove a container, but if you want to remove an image, okay, a complete image, you can use rmi. So it will remove remove a whole image from your system. Okay, not gonna be a content itself, but the image itself. Okay, the image is going to be gone. So if I have a bunch of images that is laying around, I can remove using rmi command. Okay. So we will be not using each and every command that you will see in here, but we have executed few. But we will, while we are working, we will learn more stuff on the way. Okay. All right. Use Docker commands. Docker. Okay. So there are few things that I need you guys to research on. So take a note, and you guys have to come up with the come up with something in here. Okay. So you have to prepare a note on each of topics that I'm going to do. First thing that you guys need to research on is what is the difference between virtualization, Vagrant, or we can say simply VMware or VirtualBox, Vagrant, and Docker. Okay, that is the first thing that you guys need to research on. What is the difference between those three technologies, how they are different, and learn what they are, then the differences. Okay. The next thing that you guys need to do is get Docker installed in your local machine and execute a few of the commands that we have touched upon today. So Docker basic pull, Docker RM, Docker containers, running those containers, whatever you guys do. So you have to practice those things next. Okay. And by the way, when you're installing Docker, you might get an error on something like if it is not starting at the first point, you might need to restart your machine. So it's better if you once you install the basic software, just restart your machine for just in case. Sometimes it happens, sometimes it doesn't. So I can't guarantee what's going to happen, but in case, it's better if you can install and um, get it done. Okay. So you guys need to learn the difference between virtual machines, Vagrant, and Docker. Then install Docker and execute these Docker commands, and you need to be learning about these things. And you guys need to um, do something like this. First thing is get into pairs, or it's like completely option. If you like, you can do it in pairs, but if you don't, the option is you guys know that when we are using Docker pull command, you can get the image from the internet, right? When you say Docker pull, it will download to your local machine from internet, via internet. It will be downloaded. But what I want you guys to do is not to download an image, but to share a downloaded image. So for example, I have, let me see, Docker images, Docker images. Okay, so I have plenty of images in here. So I have Minio, I have Hello World, I have Ubuntu, I have Mongo, Keycloak, pgadmin, Mailhog, again a Keycloak, and Nginx. So rather than using Docker pull, I will be downloading from Docker Hub. What I need you guys to do is, rather than downloading it, you download once. Okay, you need to pull one image. Say for example, I have downloaded the Docker pgadmin, and if I say Docker images, it is showing in here. and your friend's machine does not show it. It is not showing the, unless he or she pulled it. Uh, they don't have that Docker image. Okay, so take something like this. Okay, you say, I will download this, I will pull. Okay, rather than saying download, I will say the exact word. I will pull this Docker image, and your friend have to download or pull a completely different Docker image. So within your two machines, you guys have two different Docker images. Okay, you might have a Docker Ubuntu image. The other person might have a Nginx image or a Mongo image or Alpine image. Okay, do not download huge images. Okay, as I have seen, when you're browsing through Docker Hub, just take a small one. Okay, the Hello World one is, you can someone take the Hello World one. It is like really small, if I can remember. It's around like 9 kilobytes. Okay, that is like the simplest form, but anyone else can take very small one. Someone can take yeah, you guys can see there are like a lot of images. Like instance, the key clock one is 668 MB, and there are like some images are really small. Find a very small one. Okay, not for like GB. There are like, you guys can see there are images like more than 2 GB in my machine. Okay, so you guys don't want those kind of things, but take a small image, make sure the image is not in the same in both machines. What you have to do is, you, without sharing, without pulling it from the Docker registry, you guys need to share the image. Okay, so at the end of the transmission, both of you guys should have the image that you have not downloaded. Okay, without using Docker pull, you guys need to share the image with someone else. Okay, so you can use different techniques. You can copy it via a USB drive, or you can share it over a network, whatever the mechanism. What you need to do is, you need to have the Docker image within your friend's machine, and you need both of you guys work alone. That means you don't tell your friend how you're gonna do it, but you need to make sure that other person gets it somehow. Okay, so do that exercise. Anyone have any question on that? Anyone I need to clarify more? Everybody got the idea? Raise your hand if you know what to do. Raise your hand if you got the idea. Okay, very good. Others? Others need more explanation. Okay, a few of you guys have the idea. Talk among yourselves, then you guys will get the perfect idea. Okay, so basically, one person download a different kind of image, the other one is completely different image. At the end, you guys need to share it without using Docker pull command. Okay, you can't use Docker pull, but you have to share it somehow. Okay, take that challenge in there. Okay, practice Docker and practice the difference and everything, and have a look around it. We'll be going through a lot of things when it is like Docker and everything. So you guys need to buckle up your uh, Docker belts. So we'll look into way more interesting stuff in upcoming lectures. Okay, so be prepared. Pull some images. Log into an image, do something crazy. You can do whatever you want within that image. You can even remove the file system as all. It won't matter. Okay, do not accidentally delete your host operating system, but anything within the container, you can do anything, and it will won't affect. Okay, but be careful what you're doing. Okay, anything else that you guys need clarification? Any help that I can provide? Anything that you guys need to know about from today's lecture? Okay, if not, I'll stop recording, stop sharing.